Alright, now let's talk about friction. So, if I'm going to take this eraser and slide it down this box, there's going to be a certain angle that I lift the box to where the eraser will start to slide. Now you can see it here. I lift, 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 nice and slow, and there it goes. So right here, about this high. Now, I'm going to double the eraser's mass here by adding another eraser on top, and we're going to see what happens. Lift, 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 getting close to the same point where it slid before, and right about at that same height, it slides again. So what's happening here? How come when I doubled the mass, it still started to slide at the same angle? Well, let's take a look at our diagram here. So we raise it to an angle of theta, and this is the instant before it starts to slide. Now at that instant before it starts to slide, we know that our parallel component of gravity, the force trying to make it go down the ramp, is being cancelled by the force of friction between the surface of the ramp and the surface of the eraser. So those two forces are cancelling out, giving us a net force of 0. So it's not moving, we have a net force equal to 0. So that means our force of gravity parallel and our force of friction are adding together to give us 0. So knowing that, we can solve for our force of gravity parallel and make it equal to the negative force of friction. So we just subtracted this over. So why doesn't the mass matter? Well, that's for you to prove to me in the question below. Now a hint for you would be to simplify this equation here. So plug in your mg, plug in your mg here, and plug in the proper trig functions, and see what happens to the mass when you've simplified as much as you can. Good luck, and I'll see you in the next video.